My name is Nirmal Hansen, and our topic is strength of treated soil with rice husk ash waste. And the team consists of Alex Jose, Jason Jovi Malapram, Noble Mura Babu, and myself, Nirmal Hansen. So the things that we will talk in this slide is introduction, literature review, experimental procedure, discussion, and conclusion. The introduction. The appropriate soil properties are essential for construction activities. Many areas have problematic soils that require ground improvement techniques, which can be used if we look into the mining sector, the uh, some machineries need some kind of stabilization for the ground to do the mining and stuff. So it can be used in such areas also. There is a growing need to address sustainable waste management. Rice husk ash is a waste byproduct from the rice mill industry. Large volumes of RHA are currently disposed as waste, posing environmental issues. Research shows RHA has a pozzolanic properties to enhance the soil strength when used as stabilizer. Overview of the shear strength enhancement of expansive clay soil treated with very RHA proportions. Behavior of parametrics like coefficient, friction angle, and shear stress with RHA treatment. Microstructural changes in stabilized soil metrics will be discussed. Understanding how RHA can be utilized from waste to construction material findings can help address ground improvement, waste management, and sustainability issues. The key literature papers that we took for this research are five only mentioned here. The five more extra other, which will be mentioned later. The shear strength of soil by using rice husk ash waste for sustainable ground improvement, which is using the RHA as well as the cement incorporated in clay soils as subgrade layers. Found improvement in devastating stress, axial strain, coefficient, and the angle of internal friction. The next paper was investigating the impact of petroleum gas composite with rice husk ash on soil shear strength, like wet sugar plantation and RSA on soil shear parameters, incorporating two waste materials for the use of fine-grained soil stabilization, which is CCR and RHA, which is cold compression residue, and the rice husk ash paste soil stabilization is used. The optimization of strength properties and expansive soil stabilized with agricultural waste focused on use of various blenders from the agricultural waste for expansive soil to stabilize that soil and exponential logarithmic models of strength properties and latex soil treated with cement and rice husk ash as pavement for low-cost roads. These are the papers we used for the literature review. Thank you.
I myself, Noble Mora Babu, and I will be discussing about the experimental procedures that have been conducted in the research topic. And the tests are conducted in three phases. First is the triaxial compression test, and the second one is the direct shear test, and the third one is the unified compression test. In the triaxial compression test, the shear strength, the shear ratio, and the friction angle of the soil sample is determined. The experiment is carried out in a triaxial apparatus, and it consists of a soil specimen which is encased in a rubber membrane and placed in a triaxial cell. The sample is subjected to confined pressure and the triaxial loaded until the failure occurs. The stress strain data is recorded and calculated to determine the stress ratio. The parameters are measured and the friction angle is calculated from the relationship between the shear stress and the normal stresses. The axial strain is the change in the length of the specimen during the loading. In this test, the types of test considered are the consolidated undrained and consolidated drained, and are two main types depending on the whether the drainage is allowed during the test. The next test conducted is the direct shear test. It determines the shear strength and the friction angle of the soil. As soil specimen is placed in a shear box and which is split into two halves. The top half is moved horizontally relative to the bottom half and inducing the shear stress in the sample. The normal stress is applied to the top of the sample. The test continues until the soil fails and reaches the specified strain limit. The parameters measured in this test are the shear strength, which is the maximum shear strength the soil can withstand before the failure, and the friction angle is also measured in this test, and it is calculated from the stress strain curve using Morse column failure criteria. And the next test conducted in this experimental procedure is the unified compression test. It is a common test which is conducted in the compression of a soil or any specified material. But in this research, we are using this test for uh, getting the information about the soil cohesion, which contribute to the shear strength. In this experimental procedure, a cylinder soil is specimen is actually loaded until it fails. The test provided data on the stress strain behavior and the unified compressive strength of the soil.
Considering all the laboratory tests, we came to a discussion that when we take in account shear strength, the untreated soil will be having 100 kilopascal, whereas the treated soil with RHA will be having 150 kilopascal. So there is an improvement, a increase in shear strength of around 50% is seen with the addition of RHA. Uh, when taking in consideration with shear stress ratio, there is also changes. Untreated soil will be having 0.50, whereas treated soil with RHA will be having 0.70, and improvement in shear ratio by around 20% with the addition of RHA is seen. Uh, when we take friction angle, the untreated soil is having around 25 degrees, whereas the treated soil with RHA will be having 35 degrees. So there is an increase in friction angle of around 10 degrees, indicating a significant improvement in the soil stability. Overall, the use of uh, RHA as a soil stabilizers not only enhance the overall strength but also aligns with the sustainable practice by recycling agricultural waste and reducing reliance on traditional stabilizers. When taking the unconfined compressive strength, there's a graph shown here, which shows that as the rice husk ash RHA percentage increases, the unconfined compression strength also increases, even if it's 3 day, 7 day, 28 day, or 56 day. Each of the graph is showing a increase in the unconfined compressive strength. Uh, when taking in account with effect of RHA and lime mixture on friction angle, the first graph shows soon after mixing, and the second graph shows 28 days after mixing. Uh, when it's a 0% lime is added, we can see a increase in internal friction angle. Even if it's 10% lime, there is also we can see a increase in internal friction angle. Same as the case after 28 days of mixing, we can see a steady increase in internal friction angle as the RHA percentage and percentage of lime increases.
Hi, my name is Jason. I am focusing on conclusion in our research. The addition of rice husk ash significantly enhances soil strength, including unconfined compressive strength and cohesion, while also improving shear strength, shear stress ratio, and friction angle. These improvements lead to more stable soil for construction projects. Using RHA as a soil stabilizer is a sustainable practice that recycles agricultural waste, offering a eco-friendly, cost-effective alternative to the traditional methods. The application of RHA in soil stabilization supports resilient stable soil structures, and sustainable development, particularly in rural and developing regions. These findings underscore the potential of RHA as a valuable resource in geotechnical engineering and soil stabilization. By utilizing RHA in a construction project, we can achieve stronger, more resilient soil structure while also contributing to a greener, more sustainable future. Its application in soil stabilization can lead to lower construction costs and increased efficiency, particularly in rural and developing regions. The potential for broader implementation of RHA in a geotechnical engineering is evident, making it promising choice for future projects. These all are the 10 references we have taken for our research. Thank you.